In today's session, I will revise the density, that is material density and population density, using the formulae to solve problems in real world scenarios. Well, there are two kinds. First one is the material density. Material density. So while computing density of copper and density of wood, those kind of things, we take mass per volume. Mass per volume. When you are taking the population density, uh, how crowded this one gives you an idea. So when you take the population density, then we take the numerator is number of people, number of people over area of location, area of location. One worth noting point is when you compute the density of a material, if the density is greater than 1 grams per cubic centimeter, then what happens is that object sinks in the water. Suppose if the density is less than less than 1 gram per cubic centimeter, that floats on the surface of water. Anyhow, while explaining the problems, I'll make use of this point. So let's quickly jump to the first question of today's session. So there is a table of questions. The first question, so let me read and identify what the given information is. What is the density of a billiard ball that has a volume of 100 cubic centimeters? So here I see that volume is 100 cubic centimeters, and I see that mass is 250 grams. Mass is 250 grams. Just now we discussed that density equals to this mass per volume. Mass per volume. So, what are the information is given, that is copied here. Mass is 250 grams and volume is 100 cubic centimeters. Now, those values are plugged in here in the formula. You can see that numerator is taken as 250 and denominator is 100. Make use of calculator and it is 2.5 grams per cubic centimeter. So let's give a try with one of the questions. Let's say that, let me take the next one. A loaf of bread has a volume of 2270, that is 2270 cubic centimeters. So first of all, let me write that density equals to mass per volume. The formula is copied. And next, let me read the question. Let me underline the key information. I see that a loaf of bread has a volume of 2270 cubic centimeters, which means volume is given as volume is given as 2270 cubic centimeters or centimeter cube. And next, I see that mass is given as 454 grams. So mass is 454 grams. Now, density equals to mass per volume. Mass goes to numerator and volume goes to denominator. Therefore, 454 grams divided by 2270 cubic centimeters, that's the denominator. So let me quickly grab my calculator. Here 454 divided by 2270. That is zero point 0.2. So this is zero point 0.2 grams per cubic centimeters. So here the point is the density is less than 1 gram per cubic centimeter. That indicates that bread floats on water. If you want, you also might have been experienced that when you take some bread slice and if you put it on the surface of milk or maybe water that floats, after a while it sinks because the bread slice absorbs the liquid, then it sinks. Otherwise, it floats on water. Okay, so let's quickly go to the next question. The next question is, let me write the formula once again. Density equals to mass per volume. Mass per volume. Let me read the question now, the second one. A block of wood has a density of zero point 0.6 grams per centimeter cube and a volume of 1.2. What is the mass of the block of wood? Here the question is, what is the mass? They are not asking to find, what is the density. So here let me introduce a magic triangle. What is a magic triangle means? You draw a triangle. Of course, the triangle is not going to do any magic, but there is a funny and interesting thing in this one. And you may take an English alphabet, let's say T. Okay, and let's write the rule, which is density equals to mass per volume. So let me write that density equals to mass per volume. Now, anyhow, you know that the density rule, which is mass per volume. Suppose if you want to find what is the mass, if you are asked to find what is the mass means, here I am striking, but if you are using your thumb or some whatever the finger, maybe indicating finger, and close that, close whatever is to be computed. Again, I'm repeating, if you want to find the mass, what you do is use your finger just to cover that part. Let it be mass or maybe volume. Just you hide it. So in this question, I was asked to find what is mass. So this is not the formula. So the question says that please see that what is the mass of the wood. Okay, so mass equals to, so let me strike this part. So density and volume, these are occurring side by side, then you have to multiply them. Therefore mass equals to I'm writing ma. Here it is density times volume. Well, let me copy the information. A block of wood has a density of zero point 0.6. So density is zero point 0.6 grams per cubic centimeter and volume equals to 1.2 cubic centimeters. As I mentioned before, you are asked to find mass. Mass equals to density times volume. Now let's plug in these numbers. Density is zero point 0.6. Volume is 1.2. Let me grab my calculator. It is, I guess, 0.72. Still, let me check. 0.6 times 1.2. It is 0.72. Anyhow, this is the mass. 0.72. Don't forget to mention the units. Based on the question, I see that it grams per centimeter cube. Therefore, whatever the mass I got, the mass is 0.72 grams. Done. Anyhow, I'm skipping these questions because these kind of questions are explained in the coming up slides. So let me quickly go to the next page. A rectangular block of copper metal weighs 18.96 grams. Weight and mass. Actually, these two are not the same. I'm not going deep into the science, but let me consider at this point weight and mass as same. Okay. Um, so here I'm taking mass of the copper block is 1,896 grams. The dimensions of the block are 8.4 centimeters by 5.5 centimeters by 4.6 centimeters. From this data, what is the density of copper? Okay, so density equals to, purposefully I left gap in between. Density equals to, it is mass per volume, right? So we see that mass is 1,896 grams. That goes to numerator. So 1896 grams, right? And when it comes to volume of the block is not given, but instead of that, the dimensions of the block are given, right? So what are the dimensions means? It is 8.4 centimeters by means here times 5.5 centimeters by 4.6 centimeters. Rectangular block means that is giving me an idea of something like a brick kind of shape. If it is the case, what is the volume of a rectangular prism means? As you know that is length times width times height, right? Therefore, let me take volume equals to, which is length times width times height. That gives me the volume, right? Therefore, let me take volume of the rectangular block. So how to multiply means I have a calculator. So let me take 8.4 times 5.5 times 4.6, 212.52. Therefore, volume is 212.52 cubic centimeters. That volume goes to the denominator, 212.52. Again, I'm repeating, you know, density equals to mass per volume. Mass is here and volume goes to the denominator, right? Oops, my bad. So volume goes to the denominator. Now just plug in these values. We have done it, and then use the calculator. Um, 1,896 divided by 212.52, that is giving me 8.92. So it is 8.92 grams per cubic centimeter. Though it is not mentioned in the question, just I would like to take that. I see that the density of copper is 8.92. As I mentioned before, this is greater than 1 gram per cubic centimeter. So if I take any copper object, let's say that copper piece of metal, and if I drop it on the surface of water, as the density is more than 1, then it sinks. Then you may get a doubt how a ship which is made of iron still that floats. That we'll discuss later. Maybe I would say that it because of the huge volume. Anyhow, let's go to the next one. Here, a table of values are given. Use the data below to calculate the density of each unknown substance. Then use the density chart above to determine the identity of each substance. That means mass and volume of some substances are given, and you are asked to check what substance it is. Okay, so let's look at the question one or the example. mass is given, volume is given, density equals to, you know that mass per volume. So mass is taken numerator, volume is the denominator, and it is computed. Density is 13.5. So once when you find the density, you look at the table where is 13.5. Once when you identify that, then you can identify what the material is. So that is mercury. That's what copied here. Okay. So this is a simple example. This is a simple example. So in the same way, let's take the next question. I see that mass is given as 171 grams, volume is 15 cubic centimeter. Therefore, let me compute what the density is. Mass is 171 grams. Next, volume is 15 cubic centimeters. So let me take my calculator and compute what is 171 divided by 15. 11.4. So it is 11.4. Now let's see where is 11.4 in the table. Oops, my apologies. I have to take, okay. So 11.4 is the density here, and I see 11.4 here in the table. Therefore, what's the material? It is LEAD. It is not lead, it is lead. Well, so the material is lead. Let me take one more question. Mass is given as 148, volume is given as 40. Therefore, density equals to mass per volume. Mass per volume. Now, let me plug in these values. Mass is 148 grams and volume is 40. So, let me grab my calculator. You also can do the same. So, 148 divided by 40, 3.7. So density is 3.7 grams per cubic centimeter. Of course, that's already mentioned here. So whether you write it or you don't, it hardly matters. So where is 3.7 means? I see that in the table 3.7 is here, 3.7 is here. So what the material means? It is aluminum. Therefore, in the table, let me mention this one. It is aluminum. Okay, so rest of the values in the table, I'm leaving it for you to do it on your own. Then let's quickly jump to the next question. Find the density of the following. Which of the following floats on water? Explain. You know, we have a good experience that if I keep a brick on surface of water, it sinks. Whereas a log of wood, the interesting thing is, look at this one. Brick is 2.3 kilograms. For sure, it sinks. And the log of wood is 18 kilos, which is heavier than a brick. But still, the log of wood floats. How? Let's check it here. We know that density equals to mass per volume. Mass per volume, right? And here I see that mass of the brick is given as 2.3. When it comes to volume, volume is not given, but the dimensions are given. So if I know the dimensions, can I compute the volume? Yes, easily, right? So let's start working on computing volume of the brick first. So volume of the brick, I see that it is in the shape of a rectangular prism. Volume equals to length times width times height. Let's plug in these values. Length is 20 centimeters. Width is 10 centimeters and height is 5.7 centimeters. So let me make use of my calculator, which is 20 times 10 times 5.7, 1140 cubic centimeters. Well, so I know the mass, so this can be plugged in here in the numerator, and I know the volume. I know the volume, therefore, volume can be plugged in here, right? Then mass is 2.3 kilograms, 2.3 kilograms, and the volume is here 1140 cubic centimeter. Please notice that the tricky part here is the units. Earlier we computed grams per cubic centimeters, but here kilograms are there. Then how to compute? In grams? I hope you remember that 1 kilogram equals to thousand grams. Okay, so please remember this one. 1 kilogram equals to thousand. It is not 100. It is 1,000 grams. So 2.3 kilograms means in the place of kilogram, I have to take 1,000 grams and multiply. I have to take 1,000 and multiply. So 2.3 times 1,000, it is 2,300. But I know that if you want, I'll compute on this one. 2.3 times 1,000, it is 2,300. So this is 2,300 grams over 1,140 cubic centimeters. So let me make use of my calculator. 2,300 divided by 1,140 cubic centimeters, 2.01. So I got the density as 2.01 grams per cubic centimeter. Okay. Already I told you that if the density is more than 1 gram per cubic centimeter, if it is more than 1 gram per cubic centimeter, then this one sinks. Okay, again I'm repeating, please don't forget, if the density of the given material or the object, this one is more than 1 gram per cubic centimeter, means what happens is for sure this is going to sink. Okay, now let's go to the second part of the question. A log of wood is given, then it is 18.1, which is heavier than a brick, but well, will it float or not? Let's check it. Okay, so let me write again. Density equals to mass per volume. Mass is given 18.1 kilograms, and volume is not given, but the dimensions are given, right? So let's try to find what is the volume of this log of wood. It seems this is in the shape of a cylinder. This is in the shape of a cylinder, right? Therefore, what is the volume of a cylinder? What is the volume of a cylinder? I hope you remember that volume of a cylinder is pi times radius square times height of the cylinder. You know that the value of pi equals to 22 over 7 or 3.14. You can take either of these. And radius is 28. It is not. Please notice that here edge to edge is given as 28. That is indicating that that's the diameter. I repeat again, edge to edge is given as 28 centimeters. That indicates that this is the diameter. This is the diameter of the log of wood, or diameter of the circle, right? So what is radius means from the center of the circle to this one. So that is half of the diameter, that gives us 14, right? Half of 28, that gives us 14 units. That's the radius. So in the place of radius, it is 14. Please don't be in a hurry and don't take 28. If so, you'll end up with the wrong answer. And what is the height means? I see that it is 44 centimeters. Let's make use of calculator. 22 over 7, or you may take 3.14. I'm taking here 3.14. 3.14 times radius square, which is 14 square, times height is 44, which is 27,079.36. 27,079.36, of course, cubic centimeters. Now, let me plug in these values. Mass here, which is 18.1 kilograms, 18.1 kilograms. In my previous example, I mentioned how to convert kilograms to grams. That we'll do it in the next step. And the volume of this one already we computed. We ended up with 27,079.36 cubic centimeters, right? In my previous calculation, I mentioned that if there is a kilogram, instead of kilogram, you take 1,000 grams and multiply. So let me multiply 18.1 times 1,000. It's very easy. It is 18,100. But still, let me compute times 1,000. It is 18,100 is divided by 27,079.36 cubic centimeters. So 0.66. Then I got the density. Is this as 0.66 grams per cubic centimeters. Friends, please notice that density of this one is less than 1 gram per cubic centimeter. 1 gram per cubic centimeter. So, if it is less than 1 gram per cubic centimeter means, please notice that whatever the density I got for the log of wood, which is 0.66, which is less than 1. Okay. Therefore, already we had a discussion earlier that if it is less than 1 gram per cubic centimeter, then that floats on the surface of water. Don't forget, less than 1 gram per cubic centimeter that floats, more than 1 gram per cubic centimeter that sinks. Okay. Any questions? Please quickly type in the chat box. Well, Neil Glenberg, astronaut, has returned to the Kennedy Space Center with samples from his recent travels. He has 3,470 grams of soil. So, this one is indicating the mass. So, he has 3,470 grams of soil from Mars. Given that Mars has an average soil density, okay, so density is given, mass is given, and what is the third element means, that is the volume, right? So the question is how many cubic centimeters of soil is that? That means you are asked to find what is the volume. Okay, who knows? You may become as a scientist and you may go to NASA. Well, so the question says that what is the volume? Otherwise, let me list out the details. Mass of the soil is given as 3,470 grams. Okay, and the density of the soil is given that 3.93 grams per cubic centimeter. So the missing element is obviously the volume. You know that density equals to mass per volume, but you are not asked to find the density, you are asked to find the volume. Therefore, as I mentioned before, you may draw a magic triangle first. A magic triangle. Okay? So, after drawing this magic triangle, okay, inside this one, you take an English alphabet. Let's say that T. Okay? Oops. I'm taking English alphabet T. Then write what the condition or rule for density. You know that density equals to mass per volume, right? So again, a quick reminder: in case if you are asked to find mass, you may use a thumb and just you close it. Mass. Suppose you are asked to find volume, use your thumb or maybe indicating finger and close the volume part. But here, what I am doing is I'm asked to find the volume. I'm asked to find the volume. Therefore, instead of closing, virtually I cannot, so that I'm striking this one. You see that mass over density, volume equals to mass over density. So let me write that volume equals to volume equals to mass over density. This is what I got from my magic triangle. Now just plug in these values. What is mass means? That goes here to the numerator, and density that goes to the denominator. As simple as that. Therefore, 3,470 divided by density is 3.93. Okay, you know what to do. You take the calculator, 3000, punch it on the calculator, 3,470 divided by 3.93. 3.93. Okay, 882.95. So 882.95. Anyhow, this is the soil brought from Mars. So, the units, if you look at, if you read the question, I see that grams per cubic centimeters. Therefore, the units must be cubic centimeters. Now, let's look at the options. 880, oh, we have the answer here. Okay, questions on this, please. Really quick, you may type your questions if you have any in the comment box. Thank you. So let's go to the next question really quick. The population density of Thamville is 17.5. So here the density is given. The density is given 17.5 per acre. Therefore, let me write the details first. Density is given as 17.5 thems per acre, and next exactly 840 thems live in Thamville. So this is the number of people. This is the number of people who are living. Number of people, which is 840. How many acres is Thamville? Which means you are asked to find what is the area of the location. So let's write the condition or formula. You know that population density, population density. Oh, well, here, my apologies before going to write this one. The question is you are asked to find the area, right? So, how to find the area means let's take the magic triangle once again. So, let me draw the magic triangle. Then, let me take my pen and please remember that population density rule is population density is slightly different. Density equals to number of people. Due to lack of place, I am writing NO. Don't think as no people, it is number of people. So it is number of people over area of the location. So here you're asked to find the area. As I mentioned before, you may use your fingers, you draw the magic triangle, then hide it with your hand, whatever is to be computed. You may use your thumb or some finger, just unclose that. So here, let's say that this one is, I'm striking, or else say that I have to find what the area is. Okay, so area equals to number of people divided by density. Number of people divided by density. Therefore, let me write the condition. My bad. So it is area equals to area equals to number of people divided by density of population. Just plug in these values, number of people that goes here, and next density goes to the denominator. Oh, my bad. Okay, so number of people, it is 840 divided by density is 17.5. So let me grab my calculator and compute, which is 840 divided by 17.5. So 48, therefore, is 48. Now, you should get a doubt. Is it 48 miles or 48? What is that? So you have to read the question. The question says that how many acres? Therefore, that is 48 acres of land is the area. Mm, I see that 48 is here. You see the rest of the options, especially 480, this is pretty close. You have to be very careful while choosing the answers. So let me go to the next question. A tree harvester estimates the height of a white pine trunk to have a height of about 19 meters and a base diameter of about 0.82 meters. The wood has a density of 390 kilograms per cubic meter. Find the mass of the trunk to the nearest kilogram. So, first of all, let's identify what is the important information given here. The height of a trunk is given 19 meters and base diameter is of about 0.82 meters. And next, the wood has a density of 390 kilograms per cubic meter. Find the mass. You are asked to find the mass. So, I'm not a good artist, but let me give a try to draw the trunk shape. The shape of the trunk is like it's a cylinder, right? So, okay, this is the tree trunk, and I see that the height is 19 meters. So this is 19 meters, and the diameter. So diameter means edge to edge, which is 0.82 meters. You're asked to find the mass, so you know what to do. We have to take a magic triangle, which I'm drawing at the bottom. Really quick, here I'm writing all the rules. All of you know that density equals to mass per volume, right? So density equals to mass per volume. This time you are asked to find what is the mass. You are asked to find what is the mass, right? Therefore, mass is to be masked. Mass is to be masked. So, if this one is masked, density and volume are left. Please notice that these are occurring side by side. So, it is not density over volume, but it is density times volume. It is density times volume. So, let me copy the information again. I see that height is given, height of the trunk is given as 19 meters, and next diameter is given as 0.82 meters. The golden rule is always, always, always blindly find the radius, which is half of the diameter, right? So half of 0.82 means 0.41 meters. Next one, if you want to find what is the mass, mass equals to, let me write here, mass equals to density times volume, density times volume. So what is density means, my bad, I forgot to write that information here. Density is given as 390 kilograms per cubic meter. So this is 390. And what is volume means? Please notice that the dimensions of the tree trunk is given, but the volume is not given. This is in the shape of a cylinder. Therefore, what is volume of a cylinder means? I hope you remember that it is pi times radius square times h. So pi is 22 over 7 or maybe 3.14. What is radius means? Just now we computed, which is 0.41, 0.41 square times. What is height means? You see that it is 19 meters times 19. Now, make use of your calculator, which is 3 point, instead of 22 over 7, I am taking 3.14 times uh, 0.41 square times height is 19. I got 10.02. So the volume is 10.02 cubic meters or meter cube. That value is to be copied here, 10.02. Now what is the mass means? 390 multiplied by 10.02. 3907, that is 3907.8. This is the mass, and I see that it is a kilograms per cubic meter, therefore these many kilograms. Okay, now questions on this, please. You may type in chat box. So there are some questions of this kind. At a skating rink, the people skating produced 64,800 BTUs, that is British thermal units of heat. The interior of the skating rink is 90 feet long, 40 feet wide, and 20 feet tall. To the nearest thousand, how many BTUs is per cubic foot did they produce? So it is almost similar. It is almost similar to the finding the density. Okay, so density equals to, density equals to, it is mass per volume, right? So here, how many BTUs per cubic foot is did they produce means while computing, then we take BTU in the numerator and the volume in the denominator to find it. So here you see that 64,800 BTUs, that goes to the numerator, 64,800 BTU, that is British thermal unit. And what is volume means? The length, width, and height are given here. So you know that volume equals to volume of a room or a rectangular room, that is length times width times height. So let me plug in these values. Those are 90 feet long, width is 40 feet, and height is 20. So let me make use of calculator, which is 90 times 40 times 20, 72,000 cubic feet. So let me plug in this 72,000 cubic feet. Okay. Now 64,000, this is what I'm computing on my calculator. 64,800 divided by 72,000, it is 0.9. I got that. 0.9 British thermal units per cubic feet. Now, this is the final answer I got. I see that that is matching with the first option, which is 0.90 British thermal units. So 90 or 0.9, these two are one and same, right? If you have any questions, please feel free to send an email. I hope all of you are having my email. That's it from me for today's session. See you in the next session. Bye, everybody.